Hello everyone, this is Nikhil and welcome back to our C programming series. So today we are going to learn a very important topic in C programming, that is dynamic memory allocation in C. So until now, whenever we created a variable in C, there is a size was fixed. If I declared as an array of size 5, it can only store a 5 elements, right? Not 6 or not 10. But what if you user decided the size at runtime? What if we don't know in advance how much memory we need, right? So that's where dynamic memory allocation comes in. Today we are going to learn one of the most important and powerful topic in C programming. This topic that makes it different from many other languages. Today we will understand the difference between stack and heap memory. What is Malloc? What is Calloc? What is Realloc? What is free? And what happens if we don't manage memory properly? After this video, you will not just write a program, you will understand how memory works inside your computer. So let's dive into the dynamic allocation in C. Before start, if you are new on this series or channel, so you can do like, share and subscribe this channel and click on the bell notification so you will get the upcoming video notification on your device. So let's start. What is dynamic memory allocation in C programming? So basically, allocating memory at runtime while program is running. So until now a variable stored in a stack memory, right? And size was fixed. But by using the dynamic memory allocation, the memory is allocated in heap memory, right? Size can be decided at runtime and memory can be resized. And also memory must be manually freezed. This is all about the memory allocation in C programming. So basic difference in what stack and heap memory is. Stack should be automatic memory, right? And heap is manual memory. And stack has a fixed size and heap has a flexible size. Stack always fast as compared to the heap, and heap is slightly slower than as compared to stack. In a stack, auto deletion is done, and in a heap memory must be free manually. We need to do manually free the memory in a heap. So important point is that if you don't free the memory in a heap memory, the memory leak will be done. So in a C programming, functions used in dynamic allocation in memory, all functions are defined in the hash include stdio.h, stdlib.h in the header file. So main functions are malloc, calloc, realloc and free. So these functions are predefined functions defined in the dynamic memory allocation. So one by one we will see here. So first is malloc. Malloc stands for memory allocation, right? M for memory and allocation for alloc. Alloc, that is a memory allocation. So its syntax is here. PRT, that is a variable, in the bracket data type asterisk malloc and size in bytes. So for example, integer asterisk ptr equal to integer, that is a data type asterisk malloc, size in bytes. So 5 into size of integer, whatever the size of integer into 5, it should be the size in bytes. Okay, so this allocates memory for a 5 integer. So if you want to store a value of 5 integer in the memory, so we need to allocate dynamically this is the syntax. Okay, so malloc does not initialize memory, right? This malloc function does not initialize memory. It contains a garbage values. Return null if the memory allocation fails. It will be written as a null if the memory allocation fails. We can see our example from Malloc. This is a simple program, right? Hash include stdio.h and stdlib.h. These are the two library functions or library header files we are including here in a main. Integer asterisk ptr, integer n comma I. These are the two variables. Enter a number of elements. We want to get an input from user as enter a number of elements. So we can get a number of elements into the count into the n. So we can create a dynamic memory allocation here. Malloc into n will be the number of elements into the size of integer. So if ptr equal to null, the memory allocation not allowed, right? If the memory allocation is done in the for loop, we are accessing that variable, and here next we will be print here whatever the elements we have entered here, we will be print, and finally the dynamic allocation memory will be free here. So next about the Calloc. So Calloc stands for continuous allocation. Okay, so we require in some programs continuous memory allocation. So this will be used here. Same syntax but number of elements into the size of each. Okay, this is an example. Calloc always is different from the Malloc. Okay, so initialize the memory to 0 and takes two arguments, that is a number of elements and the size of each. Okay, the third one is Realloc, used to resize the allocated memory. So whenever we want to resize that allocated memory, so that time we need to use this predefined function, right? So syntax is here, data type Realloc ptr and new size. Okay, so reallocate whatever the new size we have to define here. Okay, for example, new size will be here. Okay, 10 into, so whatever the existing your dynamic memory allocation, we can define here with the new size of that elements. Okay, so you can increase or decrease the size of array. That time we can use the resize that allocated memory. So fourth one is free. This free function is used to release the allocated memory. Whatever we have specified that particular memory, and at the end of the program we want to free that allocated memory, that time we need to use this function. It's not used in the memory leak occur. Okay, so next one is memory leak. When allocated memory is not freed, it says occupied, right? When the memory allocation is not freed, it says occupied. In the long running programs, this causes like your slow performance, or it might be crash your code. Okay, or system memory exhaustion. That type of things will happen when the memory leaks, right? So next point is dangling pointers. So if you want to free a memory but still use a pointer, that time this concept is used in dangling pointers. Here is an example here. We want to free a size, but whenever we free the size but we won't print here. Okay, so that time this will not happen. This is the dangling pointers. It will not point to that particular freed phrase, right? Solution here is whenever we free that memory allocated, we need to define as a null. Okay, so after freezing that memory, we don't use that pointer. It should be set it to the null to avoid a memory, or sorry, to avoid a dangling pointers. This is all about the dangling mistake. These are the some mistakes while doing in the program, so we can take care about that. Okay, so finally we will conclude that this session. So dynamic memory allocation makes C extremely powerful, right? So now we understand what is a heap memory, what about the malloc, calloc, reallocation, and free the memory and memory leaks